Today, let's expand our knowledge of pointers to include dynamic allocation. This means when the program is running, allocating memory on the fly from a place called the heap. The heap is a storage location where all of your variables come from. What we're going to do is use something called the new operator to dynamically allocate memory. What it does is it gives us back a pointer to space that has just been established for us. Let's look at an example. In this case, the new operator is used to carve out space in memory big enough for an integer and to return to us a pointer to that space. We put that pointer into P1. Anytime we dereference P1, it goes to that newly allocated space. We can read data in with cin. Remember, when you dereference a variable like P1, you go to the place it points to. So we can do that to read data in with cin, and we can also do that to make changes in P1. The bottom line is read like this, from right to left. Dereference P1, get the number, and add 7 to it. When you get that answer, assign it to the location P1 points to. Here's another example of the new operator in action. num1 pointer is given a pointer to an integer. There's nothing in that space, it's just a space big enough to store an integer. num2 pointer is given a pointer to an integer that contains the value 99. Variables created with the new operator are called dynamic variables. They can be created and destroyed while the program is running, and that's what makes them dynamic. Your author has a number of examples in the textbook that show how this works. This is one you might pay attention to as you read the textbook, and display 9.3 gives a diagram of how it works. I talked about the heap. This is sometimes called the free store. It's a place that's reserved for us to store data. While our program is running, we use new to allocate space from there, and when we've allocated that space and we're finished with it, we should delete it with the delete operator. New and delete work together. When you allocate space with new, you should return that space to the free store with delete when you're finished. This is the difference between automatic and dynamic variables. Automatic variables are the ones we've normally created, ints, floats, doubles. When a function, let's say, is over, those are naturally returned to memory. But space allocated dynamically is not, and that's why we need to be careful about how we maintain it. Here's an example. We have a little function called fun. We've allocated an integer called num, that's an automatic variable, and a pointer variable called ptr, that's also an automatic variable. They were created at the beginning of the program. As the program runs, we dynamically allocate space and store the pointer in the ptr, pointer variable. Once we've done that, we can use that pointer variable for whatever purpose we want, but when the function ends, we have a problem. The space has been stranded in memory. Automatic variables are automatically returned to memory when the function is over, but dynamically allocated variables, ones that we used new to create, are not. They just sit there taking up space. Wasted space can pile up over time and make our program bog down, so we want to stop that. So if we go back to our original program, how do we use the delete operator? Like this. Keep in mind, this does not delete our automatic variable ptr. What it does is it deletes what ptr points to and leaves the pointer variable free to automatically be disposed of. Now when the function ends, we can see that the automatic variables have been returned to memory, they're gone, and the dynamically allocated space that we used new to carve out is gone now as well. It's been returned to the free store. We say that we've done our garbage collection well, and that's what we want. Now let's step it up a bit. We're familiar with the indirection operator. That's that star that we use when we dereference a pointer. pointers indirectly point to other things. So the indirection operator tells us to go to what the pointer points to. That's what dereferencing is all about. Following that reference, following that address out in memory. Well, just like we can have a variable that points to another variable, we could have a variable that points to a pointer variable that points to something else. This is called double indirection. And to do this, we have two indirection operators. It can be a little bit tricky, but I think an example will help us straighten this out. Imagine that we have a single integer variable. Nothing fancy, it's called num, and its value has been assigned to be 5. We can create a pointer variable. In this case, num pointer is a pointer to an integer, and we grab the address of num and put it in there. So num pointer indirectly points at num. Now let's create a variable that is a pointer to an int. In other words, this can point to a variable that's a pointer. Its name here is num pointer, and we grab the address of the previous pointer variable and put it in there. So now we have a situation where one pointer variable points to another, and that pointer variable points to the data. And that's called double indirection. Here's an example of how that might work in code. There are 3 variables here, a, p, and pp. A is an integer, and it has 123 stored in it. P is a pointer to an integer, and we'll put the address of A in there. And pp is a pointer to a pointer. We'll put the address of P in there. See if you can diagram the relationship between them before going to the next slide. The pointer relationships look like this. Examine the cout code to see what's printed. You should be able to figure out exactly what each of the dereferencing operators are doing. You'll notice that sometimes we're printing out addresses, and sometimes we're printing out data, like the number 123. It all depends on how we have dereferenced the variable. This is a short program. It's a good one to take to Janice and play around with a bit. That's the best way probably to learn how to do pointers, is to actually write code and write small little programs. That's it for today. Thanks for watching.